Let's look at LazySequence and LazyMapSequence. We have a Fibonacci function on the screen. It's an iterative function. Usually for Fibonacci sequence, as you might be familiar, we start with two arbitrary numbers, and then every subsequent number in the sequence adds up to the previous two. But here we're starting from 0, so 0, 1, and then every subsequent number in our sequence is going to add up to the previous two numbers. Now, in a function tracks the last two numbers, obviously, and then the variable updates, and then it counts up. Now, here we are doing close range from 0 to 20, and then we're calling this dot map method, which takes our Fibonacci function, and then this returns an array. So we can do this random access by requesting for the 11th item in our Fibonacci sequence. So that's 55. In any case, this is a fancy way of, so we could have done something like this, dot map, and then here we do num in Fibonacci, and then here we can just pass num, and then we still get the same as before, same result as before. Now, what we're hoping to do is to optimize this operation, because this is not quite optimized. As you can see here, what this is doing is it's mapping, it's iterating through everything here from index 0 to 20. But then we are requesting for the 11th item in our Fibonacci sequence. So there's no need to run through all this loop if we're just going to request for a specific item in the sequence. So the way to optimize this is to lazy load this. So we can turn this, instead of a sequence, we can turn this into a lazy sequence. And then when we apply the map method, it becomes a lazy map sequence. So what I'm trying to say is, instead of doing this, I'm going to go back to the short form way that we did before. So it's going to map, and then we buy Fibonacci here, Fibonacci, like so. So when this maps, it just passes the value into our Fibonacci function. Remember, functions are first-class citizens. We can pass them around like this. So in order to optimize this so that we don't map through everything, we can just do here, we can do dot lazy, like so. Now this becomes a lazy map sequence because we're applying this map to this lazy sequence now. So here it says no exact matches in call to subscript. That's because where before now we were returning an array. Now what is being returned is a lazy map sequence. So unlike a standard Swift array, lazy map sequence does not store values in memory. What it does is it calculates values on the fly based on request. So here we're trying to access this 11th item in memory, but it's not there, can't find it. So we're getting this error, no exact matches in call to subscript. Okay, so how do we fix this? Well, there are a couple of ways we can fix this. We can explicitly turn this into an array again. So we can do cut this and then say array. So this is Swift array constructor, and then in here we can just paste this. And this becomes it becomes an array as before. So we can do print sequence, and then so we get a 11th item as before. So we still get this 55. But then this isn't exactly what we want, because so there's no point trying to convert it back to an array. It doesn't really make sense. So what I'm going to do now is I'm going to implement something that is lazy and stiff, far more efficient than this. So I'm going to remove this array, and then I'm going to use dot drop dot false with dot drop first. So so we have this, and then here, instead of printing this, I'm going to do if let value equals sequence dot drop first. So drop first, let's say 10 dot first, like so, and then here we're gonna print value. Hope I didn't mess that up. Okay, so that's an issue here. Okay, so now what this is doing is, okay, it's dropping the first 10 elements here, and then it gets the next one. So we're getting our 11th item back like before. So it's this is now lazy loading. It's not looping through everything. So it drops the first 10 items in our sequence, or in our range now, in our close range, and then it gets the next one, which is 55. Now imagine a scenario where we're hoping to do more than maybe we're trying to increase this range. Maybe we're trying to increase our sequence. For instance, if we had 199. Okay, so we're getting the first 10. This still works. What if we decide to get the 19th, the 100th item? Check this. Now our program crashes. It says the playground encountered a crash and could not finish executing. Well, that's because at this point we have exceeded the limit of standard Swift integer numbers. Remember, in our Fibonacci function, we're returning an integer type. So this has exceeded the Swift integer number value. So the way out of this, there are two ways. We can return a double, or if we're building an iOS app, we use the big int type. So what I'm going to do is I'm going to go here. In order to make this work, I'm going to go here, and instead of returning int, I'm going to return double, like so. And then this number, I'm going to wrap it in double. So essentially, we're trying to turn our return type to double. And then here in var a, the type is going to be double, double, and then a as well is going to be double, like so. Okay, now we have our result. It's not crashing anymore, because double is actually quite it stores more numbers than the standard Swift integer, like so. So this is an example of how we can optimize iterative operation in Swift using lazy pattern. So guys, I'll see you the next video.